on question 4, and question 4 says, given g of x is equal to 1 over x minus 1 plus 2. So we have to write down the equations of the asymptotes of g. Okay, so it's only for 2 marks. The asymptotes of g, you have a vertical asymptote and a horizontal asymptote. Now, how you know which one it is this, the vertical asymptote is always the one with x. So if you have an x minus 1, your vertical asymptotes equation is actually going to be, you can kind of see it like you're saying x minus 1 is equal to 0, and then you're taking that 1 over. So it's x is equal to 1. That's a vertical asymptote. And then the horizontal asymptote would be the number that appears here, which is the number for q, right? So this one is p. Now, this one, it is horizontal, so it's going to start with y. Y is equal to 2, and that is our answer there. Moving on to the next question. 4.2 says, draw the graph or a graph of g indicating any intercepts with the axes and the asymptotes. So we already have the asymptotes. To draw the graph, we just need our intercepts. So let's go ahead and find those. So our equation is g of x is equal to 1 over x minus 1 plus 2. So first of all, we can go ahead and find our x-intercept. To find the x-intercept, you just have to make y equal to 0. So our y is our g of x, of course. So we say 0 is equal to 1 over x minus 1 plus 2. And then to solve for this, you can go ahead and take the 2 over, and it becomes a negative 2 is equal to 1 over x minus 1. So you have a number, fraction, and an equal to sign. Just turn the number into a fraction by putting it over 1, and then cross multiply. So we're going to say the 1 times 1 just gives us a 1. And then we're going to say the negative 2 times x minus 1. But remember, it's 1 term times 2 terms, so it has to multiply to both of them. Okay, like that. So I'm going to go ahead and do that straight away from here. I'm saying the negative 2 multiplies to the x and gives you a negative 2x. And negative 2 times negative 1 gives you positive 2. Then because negative 2x is negative, I'll take it over and make it positive 2x. Then we still have a 2 here. And this one comes over and becomes a minus 1. Then 2x is equal to 1. And then divide both sides by 2. And therefore x is equal to a half. So that is your x-intercept. And as a coordinate, it is a half and the y value is 0. Because remember, we say make y equal to 0. So that's x-intercept. Then we need to find the y-intercept as well. So the y-intercept we find by making x equal to 0. Okay. And so making x equal to 0, that is g of, in place of x, I say 0, is equal to 1 over, in place of x, 0 minus 1 plus 2. Then let's simplify that. That is g of 0 is equal to, well, 0 minus 1 is negative 1. So 1 over negative 1 is already negative 1 plus 2. That's going to give you positive 1 because it's 2 minus 1. So as a coordinate, our y-intercept is 0 and 1. So there we have our intercepts. And now we can draw our graph. With the graph, it's quite simple. Just draw a Cartesian plane first. And then make sure to label your axes. So that is our x-axis and that is our y-axis. Okay, so now that we have that done, you can go ahead and start plotting. If you want, you can put coordinates. So I'll just put a few coordinates. It's not really that necessary though. Okay, so this is the graph. And then we just have to put down, first of all, before the coordinates, put down your asymptotes. It's very important that you do that first. So remember that our asymptotes are x is equal to 1 and y is equal to 2. The x is equal to 1 is your vertical asymptote, and this one is your horizontal asymptote. So x is equal to 1, it's a vertical line, meaning it stands up. So it's going to be a vertical dotted line, of course, that will pass 1. So like that, and then just make sure to label it. So it's x is equal to 1. And then our horizontal asymptote of y is equal to 2 is a horizontal line that will pass 2. And then remember to label it y is equal to 2. Okay, so now that we have our asymptotes down, we can go ahead and start putting down our coordinates. So remember the first coordinate we have is our x-intercept, which is a half and 0. So it's on the x-axis, it's a half and 0, meaning it is not past 1, it's here. So I'll put that there, and then I'm going to say a half because, you know, we don't have that coordinate there. So you don't have to say a half and 0 because it's on the x-axis, you can just write a half. But when it's like a point, maybe something like 3 and negative 2, then you have to actually write it down. Okay, then we have that. And then the next point that we have is our y-intercept, which is 0 and 1. So we'll just go 0 and 1. And so we can see that that goes over there. Again, I don't have to write the coordinate. Okay, there's one more thing that we need to consider now. Now that we have our intercepts, we have our asymptotes, we need to consider the shape of this graph. So the hyperbola, the general form of it is y is equal to a over x minus p plus q. You see the value of a? If a is positive, then your graph is going to lie in the first and the third quadrant. And if a is negative, then your graph is going to lie in the second and the fourth quadrant. Okay, so that's how it works. So as you can see, our a value is 1, and that's positive. So it's going to lie in the first and the third quadrant. So our graph is going to look like this. When we're sketching down our graph, we know that it lies here and here. And so let's just follow the shape that we have here. Since our graph is going to lie here as well, you see that it's going to go like this and pass that and then go down like that. So something like this, it passes like that. And then we're going to have the other wing, which is going to be here in the first quadrant. So that you can just copy the way the shape looks, and you can just go ahead and say that is your other wing. So I'll just leave it like that. If you like, you can go ahead and find another point on the graph that would also be helpful, but it's fine like that because the most important points are there and the shape is there. Okay, so that is our graph. Moving on to the next question. Then question 4.3 says, determine the values of x where g of x is greater than 0. Okay, so where is g of x greater than 0? Okay, so to do that, we need the graph. We're going to look at the graph and we're looking for, remember, g of x really just stands for y, meaning where the y values of g going to be greater than 0. The y values, okay, should let you think about the y-axis. Where you're thinking about y values that are greater than 0, these would be y values greater than 0, meaning you can only consider parts of the graph that have y values here. In other words, y values that are above the x-axis, because everything below the x-axis has a y value smaller than 0. So we're only going to consider parts of the graph that are above there. So as you can see, there is this part of the graph that we have to consider and also this part of the graph. So all we have to do is now tell them the values of x for which these parts of this graph exist on this Cartesian plane. So we're going to look at that, and we can look at this and line it down to the x-axis. You see, if you line it down to the x-axis, you see the values that you have. It starts off here at a half, okay? That's when it becomes above the x-axis. And so these are values that are moving towards this direction, which are values that are really smaller than a half. So for that, we can actually tell them that x is less than a half. Now, I don't have to say less than or equal to here because they only ask for where g of x is greater than 0, not equal to 0. At a half, g of x is equal to 0 because it has a y value of 0 there. Okay, so for that wing, we're done. Then we have to deal with this wing. So what are the values of x for this one? Well, do you see that this graph is going up there and it's going to get closer and closer to this asymptote? So if you look at what's going on, these are the x values we're actually speaking about. So we can see where it's heading towards. It's heading towards the right-hand side. But where did it start? It started here after this asymptote of 1. Okay, that x value of 1. Then it was every value that came after it to the right. So this is where x is greater than 1. Okay, so we can tell them that. So or x is greater than 1. And that would be our answer for this question. There's nothing really. We cannot say x is equal to 1 because we have an asymptote there and the graph does not have a value at x is equal to 1. So moving on to the next question. The next question says, determine the equation of the axis of symmetry of G which has a negative gradient. Okay, they've been very nice in these questions, honestly speaking. So the whole question 4 was really good. Axis of symmetry, we have to think about it like this. Okay, so you see a hyperbola. if you have an hyperbola, whether it is the one with a positive a value or negative a value, does not matter. It will have two axes of symmetry. It first has the positive one, and the equation of that you just need to remember. If you remember the equation of the general equation of your hyperbola, which is y is equal to a over x minus p plus q, then you will remember this equation. It's just y is equal to x minus p plus q. See? Like in that original equation. So that's the positive one. That's the one with a positive gradient. That's why x is positive. The one with a negative gradient, if you can remember this one, you remember this one. The one with a negative gradient is formed by just putting a negative in front of x minus p. So y is equal to negative bracket x minus p and then plus q. Then if you distribute that, you see that y is equal to negative x plus p plus q. So that is the equation of the axis of symmetry of G, or of a hyperbola with a negative gradient. So let's go ahead and fill this in. So y is equal to negative x. And what is p and q? Well, we knew those values already from our asymptotes. You see that this is p here and this is q. Meaning, you see it says x minus p, x minus 1. So p is 1 and q is 2. Just like in your vertical and horizontal asymptotes. So we're just going to say we have plus 1, which is p, and plus 2. So your equation is just y is equal to negative x plus 3. That is the equation of that axis of symmetry. Okay, and that is it for question 4.